Okay folks, we're looking at some more vertical transformations of the cosine curve. Just to discuss this, we have the cosine of theta plus 2, which means the mother curve is translated upwards 2 units. Here we have the mother curve undergoing a stretch by factor 2. So where we add by 2 here, remind yourselves, here we first multiply all the y values by 2 and then we subtract 1. Now remember what I said earlier on, I keep reminding you, you have to know the mother curve's critical points. So I'm going to color them in here. Notice we're sketching from minus 270 to 270. This comes down to minus 90, minus 180 and 270. So that's the mother curve critical values. I want you to at this point pause the video folks and then go and sketch these two functions. Once you've drawn them on this particular domain, watch the video and where I give you the memo. Okay, so pause now. Okay, let's have a look. Let's work with our first graph. Our first graph, the mother curve is cos theta. And all the y values get added 2. So the y value here is 1, so it goes to 3. This one is quite straightforward. Here I go to 0 as a y value and I add 2. The curve ends up there. Add 1, add 2, add 1, add 2. Here 0, add 1, add 2, minus 1, add 1, you go to 1 up there. If you've added 2, go to 0, add 1, add 2. Now I'm ready to curve this graph carefully through the points. Remember, your cosine graph and your sine graph does not have any sharp edges or dents in it. It's rather smooth. Now folks, let's quickly talk about this again. You can see the amplitude for this curve is still 1. The horizontal for the curve moved along. The maximum distance away from that horizontal is 1. The range for this curve lies between 1 and 3. So y is bigger than equal to 1, smaller than equal to 3. The domain has been specified over there. That's my first curve. Now remember your entry and exit points. This is 270 and 2. This is minus 270 and 2. And your turning points are neatly placed where they intersect. Sorry, so let's go for the next one. We first of all going to do twice cos theta, which means you take the mother curve and you double the y values. You times by 2. So that y value of 1 will go to 2. The y value 0 will stay on the x-axis because 0 times 2 is 0. Minus 1 times 2 goes to minus 2, and then it returns to rest at 270, where the y value was 0. Y value here is 0 times 2 stays what it is here. It's minus 1, comes down to minus 2. There it's 0 again. So this part I'm only going to indicate for you just for now in fashion. Cos theta undergoing the stretch of factor 2 vertically. So this here is y is equal to 2 cos theta. It's not what we want. We want minus 1. So we go to that curve, we subtract 1 from y. Subtract 1 from that point. Subtract 1 from here. Subtract 1 from there. Subtract 1 from that y value, at minus 1. Subtract 1 here, you're at minus 3. Subtract 1 there. Now you can see carefully, if you draw this, the solid curve, you will see that it goes through those points quite nicely, and the final curve is the one in pink, solid pink. The range of the pink graph, smaller than 1, bigger than minus 3. So bigger than equal to minus 3, smaller than equal to 1. The domain again is specified. Now remember, the rest line for this curve is there. It's 2 units away from there, so the amplitude for this curve is 2. if we continue to sketch this, the period did not change for any of these two graphs. That period is still 360. Okay, folks, I'm pretty confident that by now this is becoming second nature for you.